welcome back to my channel. We are going to study about dominant epistasis. In the last video, we learned about recessive epistasis, and now dominant epistasis is also known by inhibitory genes. Now, in dominant epistasis, the phenotype is get influenced when the epistatic gene is dominant. In the last video, in recessive epistasis, we learned that when the epistatic gene is in recessive condition, that when it affects the phenotype of hypostatic gene. Here in dominant epistasis, that means the epistatic gene. Here we are talking about two genes, A and B. So A is the epistatic gene. So when epistatic gene is in dominant condition, that when it will influence the expression of hypostatic gene, that is B. So now when the F1 generation of a genotype capital A small a, capital B small b is crossed with another member of F1 generation, we get the F2 generation. As you all know, the ratio of the F2 generation 9:3:3:1. Again, I am telling you this 9 is for complete dominant phenotype when both the characters are dominant, and when both the characters are dominant, that means at least one allele should be present in the dominant form. Then only the character will get expressed. So this 9 is for A dash B dash. That means if we write AABB, then also the phenotype will be same. If we write AABB, then also the phenotype will be same because at least one dominant allele is present. So this 9 is for dominant phenotype. The middle 2, 3, these are for the one character dominant, one character recessive. So here A is in recessive state, B is dominant. In the next one, capital A, that is this is dominant and B in recessive condition. This is the reverse situation. In one, A is recessive and in the another, A is dominant. This one of the ratio is for complete recessive characters. Both the characters are in recessive state. So this we all know that in F2 generation, the dihybrid cross ratio is 9:3:3:1. Now what it is said, when the epistatic gene is in dominant condition, that when it affects the phenotype. So what are the genotypes where you can see that the epistatic gene is in dominant state? This first one and this third one. So that means these two phenotypes will get affected. So rest of the ratio will remain the same. That means 3:1. This 3 and this 1 will remain the same, and this 9 plus 3 will become 12. So the new ratio will become 12:3:1. So only what we have to remember is the dihybrid cross ratio, that is 9:3:3:1. And along with that, we have to remember that 9 is for when both the characters dominant. 1:3 is for when one character recessive, next 3 when another character recessive, and 1 is for both the character recessive. Correct? So this only we have to remember. Then depending upon what is asked, if it is asked dominant epistasis, then in that case, the genotypes where epistatic genes are in dominant state will add up together. Their ratio will add up together. If it is asked recessive epistasis, in that case, this one and this one we will add. Rest all numbers will remain the same. So that's how we get the new ratio for the epistatic interaction. Now how the test cross ratio will differ? So in the test cross ratio, as we all know, that it is 1:1:1:1. How we get this 1:1:1? That is explained in the test cross video. I would ask you to see that video if you don't know about this test cross ratio. So here also how the ratio will affect this capital A, that means the dominant state of epistatic gene. This capital A, that means the dominant state of epistatic gene. So this two will get add up to form 2 and this 2 1 and 1. So 2:1:1 is the new ratio of the test cross in case of dominant epistasis. Now, example for this is a fruit color in summer squash. It is of 3 colors, yellow, white and green. So here the epistatic gene is W and the hypostatic gene is Y, which is responsible for yellow color. So here also, these are the genotypes with the ratio 9:3:3:1, which will change here because the dominant epistatic gene is present. This one where the dominant epistatic gene is present. So here you can see this became white, this became white. Why? Because it is yellow. So here it is yellow color, and because here both the genes are in recessive state, therefore the phenotype is green. Clear? Now, sometimes we observe that this ratio changes to 13 is to 3. 13 is to 3 means already we are having 12 is to 3 is to 1. So that means with this 12, this 1, sometimes these two add up together. That means this one. Why so? Because here if you see 9 is white, 3 is white, and if suppose because of this recessiveness they cannot express any color, so they will obviously remain white. So in that condition, this one will also get add up with 12. So in that condition, we will get 13 is to 3 instead of 12 is to 3 is to 1. But both the things are for the dominant epistasis. Now your homework is to write the phenotypes in case of test cross. Do let me know in my comment section. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.